Going through plots for quantitative data. It'll stretch out over a couple of videos. So just remember to note up here that we're talking about quantitative or numerical data. So we have a different set of plots. Previously, we looked at bar charts and pie charts for categorical data. Quantitative data or numerical data, we've got a totally different set of plots. So let's start off with histograms. You can think of these as like a bar chart for quantitative data. So first thing, let's come up with our data distribution. I'm going to be talking about fat content, and we had two options in our data set. We had fat content and sugar content. Let's just check out fat content. So if you peek back at the data for fat content, you can see we have anywhere, there's 6 grams, kind of glance through 0 grams of fat. All right, so that looks like it's the lowest, all the way up to 9.1 grams of fat. Great Grains pecan, I guess there's a lot of pecans in there. Okay, so 0 to 9.1. So we need to come up with some kind of category system to label how much fat is in a particular cereal. So 0 to 9.1, I'll say 0 to 10-ish. Maybe we can group that by 2s. So I'll say 0 to 2 will be my first category. 2 to 4. 4 to 6. 6 to 8. And then 8 to 10, that should capture all of them. Now, this is just one way for grouping my possible values of the variable for my data distribution. You could count by 1.5 or 1s, or, there's several different options. But you need to make sure that your endpoints are very clear. So I notice I use different endpoints. The bracket, square bracket here, tells us that that value is included. Parenthesis tells us that we take fat content all the way up to 4, but not including 4. So 3.99999, but if we have a 4, it's included in this next row where there's a bracket with the 4. 6 would be included in this group, but not up here. So take a moment and figure out how many observations, what is our frequency of observations falling in the 0 to 2 category, that first grouping. Hopefully you found that there are 20 observations here. Any 2s go in this next grouping. The next one is 5. I'll just save you the trouble if you count through these on your own. You should have 3 in this next category. 1 and then 1. And if we double check, we've got 25, 5 more. That does give us a total of 30, which we should have. And just a reminder, you could also find the relative frequency of each of these. I'll again abbreviate if that's okay. Relative frequency, how many relative to the total? So for that first category, our relative frequency would be 20 out of 30, or 2/3. Or if you wanted to write it as a decimal, 0.6667, if we round it to 4 places. 5 out of 30 for the next, 3 out of 30, and 1 out of 30 for the last 2. Again, you are welcome to just leave it as fractions. Don't even worry about reducing them, and that should add up to 1. All right, so our histogram, same idea. We're going to put our categories on this axis, and don't try and use this strange notation here with these different brackets and whatnot. Just mark it off. 0, 2, 4, 6, 8, and 10. Keep it clean and simple here, and we can label this as our fat content in grams. The vertical axis, again, we can label it with frequency or relative frequency. It will have the same shape. So I'll keep it simple as frequency. And it goes up to 20 for the highest. So I'll count by 5s again. 5, 10, 15, and 20. Unlike the bar charts, on our histogram, our bars are now touching. So this 0 to 2 category, we had 20. Our 2 to 4 box on our number line, there were 5. The 4 to 6 box, we had 1. Oh, sorry, just kidding, 3. And then we had 1 in each of the remaining 2. So there's our histogram of fat content. Make sure you can answer questions related to histograms. So for example, I could ask something like, what percentage of cereals have at least 4 grams of fat? And you should be able to get a rough estimate just based on the plot. Now, hopefully everybody's good, but I want to pause from past experience. Almost half sometimes get this at least and at most language confused. At least means at minimum. What's the smallest, or that's the smallest that you can have. So at least 4 grams of fat is the same thing as saying 4 grams of fat or more. So I need to add up all of these guys. So my 3, 1, and 1 would give me 5 out of the 30. Multiply it by 100 to make it a percentage. All right, and if you think you're in the camp of getting that confused, at least and at most, make a little note maybe at the top of your page. I'll put it here. At least is greater than or equal to. At most is less than or equal to. And we're going to be using this a whole lot in this class, so get it clear early on. At least is that many or more. At most is that many or less. All right. Make sure you leave some room around these plots because we're going to come back in another video and make some more important observations. But first, let's get the bare bones for actually constructing these plots. Stem and leaf plot we'll come back to in just a moment. Hopefully you're not having any bad memories of that. And let's pop over to dot plots. So dot plots are really simple. Like the name suggests, we're just going to draw a bunch of dots. And let's look at our other quantitative variable, our sugar content in grams. So if you pop over, I'm not going to scroll, but if you look at the data on sugar content, you'll notice it ranges from about 0 grams of sugar up to 20 grams of sugar. I'm going to count by 2s here, draw my axis. Notice in all of these cases, you label, I can't talk and count by 2s at the same time. You should label your axis before you put any data on there to make sure it's all drawn to scale. This is true all semester long, always. Okay, so hopefully I've counted by 2s correctly while I was talking. Then you're going to go back and look at your plot or your data for sugar content. And actually, I'll go ahead and look with you guys. So if we scroll back and take a look, we'll notice sugar content, the first observation is 14, the next is 20, the next is 15. Let's try and remember those, 14, 20, and 15. So go back to where we were for dot plot. And we'll just really draw dots for those observations. So dot at 14, the next one was a 20, and the next one was a 15. And we'd carry on this way until we have all the data represented. So rather than scrolling back and forth, I'll help you out here. 0, we had a couple of observations with 0. If you have more than 1, just stack the dots like this. So 2 observations with 0, sugar, probably my grandma's cardboard brand cereal she has every morning. 2 2s. We've got 3 cereals that have 3 grams of sugar. We've got 2 with 7 grams of sugar, 1 with 9 grams of sugar. We've got 4 that have 12 grams of sugar. We've got 3 with 13, 4 with 14. We already had one of them there, so don't overdo it. A couple of 15s, 4 16s, a 17, a 19, and then we already put the 20. So here's our distribution, our plot that kind of helps us get a feel for how sugar content is spread out across our different cereals. Now I did this first to kind of help us out with the last one we'll be talking about, this stem and leaf plot. So you'll notice this little comment here that says 10 leaves per stem. 10 leaves per stem does not mean you're limited to 10 observations on each stem. It means you have 10 options, the numbers 0 through 9. But as you'll see in our example, you can have a lot more than 10 numbers there. So just as a reminder, our last digit goes on the right side, or the stem, or the right side of our plot here has the last digit. And then, oh, just kidding, I got those mixed up. This is our leaf, excuse me. And then the stem is on the left side. It's going to have all other digits. Now, sometimes you might have numbers that are really big, and a stem and leaf plot in those cases, you're probably going to round those numbers to the nearest 2 digits or something like that to make it more compact. So let's actually look at stem and leaf plots for both of our data sets. Let's start off with sugar content, since we just made a dot plot for that. So we need our two parts to the plot. Our left side, we need our stem. And then the right side, we need our leaf. Now, if you remember, our leafed. If you remember the data for this, and actually let's go ahead and take a peek back at it for a moment. So before we do that, leaf is our last digit. All other digits go on the left side or the stem. So if we check back with the data, for our sugar content, they're all basically 2-digit numbers. And they're in the 1s, the 10s, and then we have the 20. So think about what that would look like for our stem. What are those first digits that we need? Well, in this case, we would need 0 for all the single-digit numbers, 1 for all the 10s, and then 2 for our 20. So looking at the data, I'm not going to keep scrolling back. You might find it helpful to kind of have these pages butterflied in front of you. But we've got our stem of 0. We have 2 different values that have 0 sugar content. We have a few that have 2 grams of sugar. We have 3 observations that have 3 grams of sugar. We have a couple that have 7 grams of sugar, and then one that has 9 grams of sugar. So this 0 represents all these single-digit numbers. And then the next row is all the ones that are in the teens. So if you look carefully through that, we had 4 12s. Again, it might be easier just to look at the dot plot since we had it arranged already. We've got 3 13s. So I'll put those here. So 1 2 represents 12, 1 3 represents 13. We had 4 14s, a couple of 15s. We had 4 16s, a 17, and a 19. Notice this has a whole lot more than 10 leaves on that stem. But again, what we mean by 10 leaves per stem is the possible values I can put here are the numbers 0 to 9. Then we also had our 20, which is here. And we'll make a little key so we're aware of the scale here. So for example, this 1/2 represents 12 grams of sugar. All right, we can do the same thing for the fat content, so if you look back and maybe even remember from our histogram, our fat content was anywhere from 0 grams of fat all the way up to 9.1 grams of fat. So I'm going to use the values on my stem of 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And I mentioned that 9.1, so I'll go ahead and put that here, 9.1. And if you look back at the data, let's go ahead and scroll there real quick for reference. So fat content, the first observation is 6 grams of fat, 6.0. The next one is 4 grams of fat, 3 grams of fat. Let's see if we can remember those, 6, 4, and 3. So on our plot, 6 grams of fat would be denoted 6 with a 0 here for 6.0. 4 grams of fat, 4.0. 3 grams of fat, 3.0, and so on. So let me help you out here with the rest of this. We should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of these have no fat whatsoever. So 12 zeros in this first row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we have 4 with 1 gram of fat. So 1, 2, 3, 4. And 4 with 1.3 grams of fat. So remember what this means, 1.3 or 1.0. There is a 2.7. We have 4, in fact, that have 3 grams of fat even. 3 that have 4 grams of fat even. There are none with 5 grams of fat, so be very careful. Don't put a 0 here to indicate none, or else that would be 5.0. We don't have an observation. So you may just leave this totally blank. Make sure you keep the 5 here. We want this drawn to scale to show any gaps or stretches here, so don't omit 5, just leave it blank. If you're one that needs closure and you really got to put something there, you could put a little line like that, but it's not required. There's one with 6 grams of fat, we already saw, and then there's nothing with 7 or 8, and we finish with our 9.1 grams of fat. So in this video, we looked at lots of methods for plotting quantitative data. In the next video, we're going to come back to all these plots and look at what are we looking for in these plots. Great, we can make them, but what good are they? What are we supposed to be checking for?